Can all three numbers in a Pythagorean triple be prime? Imagine a right triangle with three side lengths that are all whole numbers. These special sets of numbers are called Pythagorean triples. Now, you might wonder if all three numbers in such a triple can be prime numbers. Let's explore this question together. A Pythagorean triple consists of three positive integers, usually labeled as a, b, and c. They follow the rule that a squared plus b squared equals c squared. This is the famous Pythagorean theorem. The question is, can all three of these numbers be prime? The answer is no, and here is why. First, in any Pythagorean triple, at least one of the numbers must be even. This is because the sum of two odd squares is always even but not a perfect square. So, for the equation to work out, one side must be even. Now, the only even prime number is 2. If the even number in the triple is 2, then the other two numbers must satisfy the equation 2 plus b2 is equal to c2. But when you try to find prime numbers b and c that fit this equation, it doesn't work out. For example, if b is a prime greater than 2, then b2 is odd. Adding for which is 2 to an odd number results in an odd number. But c2 must be odd if c is odd, and the square of an odd number is odd. So in theory, it might seem possible, but in practice, no prime triplet satisfies the Pythagorean equation with all three numbers prime. Another reason is that the formula for generating primitive Pythagorean triples involves two numbers, usually called k and l. The sides are calculated as O is equal to k2l2, b is equal to 2kl, and c is equal to k2 plus l2. Notice that b is always twice the product of k and l. Since k and l are integers greater than 1, b will always be even and greater than 2, making it composite. So even if a and c are prime, b will not be prime because it is a multiple of 2 and the product of two integers. This pattern shows that all three numbers in a Pythagorean triple cannot be prime. You can find triples where two numbers are prime, like 3, 4 and 5, or 5, 12 and 13, but not where all three are prime. In summary, the structure of Pythagorean triples and the properties of prime numbers prevent all three sides from being prime at the same time. One side must be even, and since the only even prime is 2, it cannot fit into the triple in a way that makes all three numbers prime. So, the answer is clear. No, all three numbers in a Pythagorean triple cannot be prime.